Typically, when we're dealing with a logarithm in a calculus class, more often than not, it's usually the natural log function, primarily because it's the inverse for the e to the x function, for the exponential function. But from time to time, we might have other logarithms that come across our plate that we have to deal with and maybe take a derivative of or something like that. And we spend a lot of time studying how to differentiate the natural log function, but practically no time focusing on how to differentiate everybody else. So that's what we're going to look at in this video. How do we take the derivative of log base a of x, where the a could be some generic base, log base 4, log base 7, log base 10, to where it's not just the natural log function. So for this, let's start by just remembering what was the derivative of the natural log function. Well, the derivative of ln of x, natural log of x, is 1 over x. Now, don't just remember that individual term. Instead, remember why it's a 1 and why it's an x. The 1 comes from the derivative of the inside of the log function divided by the inside itself. So that's really the generic pattern, is the derivative of the inside over the inside. So if it's just an x, well then yes, it would be 1 over x. So now the question becomes, what would we get for the derivative if we wanted to differentiate log base 5 of x instead of natural log? Well, unfortunately, the derivative is not 1 over x anymore. Turns out that's not the case. And you can kind of see why. There's really no reason it would be the same. If you had a different base, then that's going to change the complexion of the logarithmic graph. And so you wouldn't expect to have the same slopes everywhere because they don't all look the same. All right, so let's see here. How do we do this then? Well, here's your rule. The derivative with respect to x of log base a of x is actually very close to 1 over x. In fact, it even has a 1 over x in its derivative. However, because of this base a, there's a little bit extra that comes in here. There's some supplementary terms that don't usually appear. So here's the extra term that you get if the base is anything other than base e, which would generate a natural log function. We would tack on a 1 over the natural log of that base. All right. Now, if this was the natural log function, in other words, log base e, we see why we would never have that term. For instance, if the base was e, the natural log of e is 1, and 1 divided by 1 is still 1, and so this term basically goes away, and you just get 1 over x. But for any other generic base, it shows up, and we can still see it. All right, now, what do you do if there's like a chain rule as well? So you have a logarithm that's got a strange base, and there's something inside of the logarithm. Well, then you just have to use the combination of this rule we just learned with our old rule, the chain rule, right, where you have composition of more than one function. So here we go. We can probably anticipate what this is going to be. This is going to be the derivative of u over u, right? So that's why we had like 1 over x. So the derivative of u over u times 1 over the natural log of a, being that the base is a little bit different. So that's your most general case, a logarithm with a weird base and something inside of it. All right, so let's see if we can tackle one of these here. Here's f of x equals log base 5 of e to the x plus 1. So f prime, the derivative, will be, all right, so we'll have a fraction here. The derivative of the inside, derivative of e to the x is e to the x. The derivative of 1 is 0. And then we'll divide it by this inside e to the x plus 1. All right, followed by 1 over natural log of 5, being that this base was a little different than a natural log function. Okay, and that's it. There's really not really a whole lot more to it than that. Now, to close out this video, I always, whenever possible, like to talk about why these things happen. I don't like just giving you guys things and just saying, well, this is the way it is, and so just learn it. Whenever it's possible, we like to take some time out and explain where the heck this stuff comes from. So here's where this is coming from. Here's how somebody figured out that this really was the derivative of log base a of x. What we're going to do is use something called the change of base formula. You may have seen that some semesters ago, probably in like a college algebra class or a high school algebra class for that matter. And what it does is if you have a logarithm with some weird base 5, base 7, whatever, it allows you to change the base to something that you else that you would prefer that it be. Now, you can't just suddenly just take the a out and make it whatever you want. You have to do it in a particular way. But the change of base formula says if you have log base a of x, then you can write this as a logarithm of x divided by any logarithm of a of our choosing. So we could do log base 10 of x divided by log base 10 of a, or whatever the base you want. But we're going to be smart about it. The function that we know the most about already is the natural log function. So I'm going to use the change of base formula to write this as the natural log of x divided by the natural log of a. And I'd encourage you, test me on this. See, check, plug some numbers in the calculator and see if these really do match. And I submit that they would be the same here. So these are equal. So differentiating this guy would be equivalent to differentiating this guy. So let's see how that plays out. What would the derivative of the natural log of x divided by the natural log of a, what would that yield? Well, if you look here closely, here you have a fraction 1 over natural log of a, which is in effect a constant, right? Because since a is a fixed base, 1 over natural log of a is just going to be some numerical value. So we can pull that constant out, and we'd have 1 over the natural log of a, and then you're really just differentiating what? Well, you're really just differentiating natural log of x, which is what? Well, it's 1 over x, as it's always been. So because we were smart and we thought a step ahead, and we made the base to be e, so we got a natural log function that we're very comfortable with, then we get precisely what we had written down earlier as the derivative of log base a of x. Is 1 over x. I had the order inverted, but that doesn't matter. 1 over x times 1 over natural log of a, and it's coming from the change of base formula.